So here we go. Derivatives. I'm going to start with drawing a function. Okay, I'm going to explain you what the derivatives or the derivative of a function is. Okay, so I have a function, any function like this, let's say, that I'm going to call function f. Okay, and I'm interested, okay, listen very, very carefully, and I'm going to take a random, any value of x here. Let's say this is a, okay? So of course, this value is what?
F of A.
Okay, so this is f of a. And what I'm going to do is I'm going to take this point here, which is a f of a, and I'm going to draw a tangent line here. Okay, I'll draw a tangent. Okay, so this is a tangent line at point a f of a. Okay, so far so good, nothing too crazy. So I'm very, very, very interested in finding the slope of this line. Okay, so this slope, the slope of this line, okay, is what we're going to call f prime of a. So this is what we're going to call the derivative of that function at a. Okay, we're going to talk about this in a second, but what's important for me is to find the slope of this line, which of course is different if I take a or if I take another value here or another value here, right? At a different value of x. Okay, so obviously, if the value was here, okay, then the point would be here, and so the tangent would be something like this, which you see has a different slope. Okay, it's clear? Let me write down a bit more formally. Okay, so we are interested in the slope of the line that is tangent to the graph of f. Okay, now the slope of the tangent, okay, there's not going to be a lot of writing, just a bit at the beginning, the definition, to the graph of f at point a f of a. Okay, so at this point, a f of a is called the derivative of f at x equals a. Okay. So I just wrote what I explained to you here in this picture. Okay, let me give you the notation. I write this. So the derivative of f at x equals a is, we write it like this, f prime of a, okay? Or we also write it df dx at a, okay? So this is the Newton notation, okay? So two guys who invented this, Isaac Newton, or this is Leibniz. That's the other one who invented it at the same time. There was a big fight between the two as to who invented it first, okay? So I think Leibniz invented it first, but he took the credit. So I don't know, something like that. There's a big drama. There's drama with it. Okay, so this is the notation. We're going to use mostly this one, but in calculus 2, you will use this one. So I will use a lot of time. I'll use this one as well, just for you to get used to it. Okay. Any questions so far? Although we're doing here. Okay. So again, function. I'm interested in finding the slope of the tangent at any point on the graph, on the curve. Okay, so since the slope changes depending on what value of x, of the value of x, well, we could say that the derivative itself is also a function of x. Okay, so let me write this down. So since the slope of the tangent to the graph of f depends on x, then the derivative is also a function of x. Okay, so derivative is equal to f prime of x. Okay, it's a function of x. So the derivative, if I'm asking you to find the derivative of a function, you're going to give me another function. Okay, or if you want, df dx of x. Okay, so it depends on x as well. Any questions so far? This is the definition, pure, intuitive, and the direct definition. Okay. Now we're going to go into formalities a bit more. Okay, so we're going to put some math into this. Okay, so any questions before I advance? Okay. Change page. You done writing?
1 second, please.
Let me know when you're done. Let's draw. I'm going to draw a function, a big function here. Let me draw it big so I can see clearly. Okay. Again, my function f. And again, I'm going to take my points and a f of a. Let me just write it here. So this is, so here I'm going to take a random, not a necessarily, I'm going to take any value x, and here I will have f of x. Okay, so again, just like we did before, I'm interested in this slope. Okay, so the slope here is what I'm calling f prime of x. Okay, and this point here is x and f of x. Good. So I need to find a way to get to this slope. It's very difficult because this is curvy, and so I don't know how to estimate how slanted this is. I don't know. So I'm going to try to estimate that value. Okay, estimate that slope. So what I'm going to do is I'm going to take another value of x here. Okay, a bit further down, and I'm going to find a point on the graph which corresponds to that value of x. Okay, so right here. Okay, so let's say I'm going a certain distance h. I'm going to call this distance h. So this here is the value x plus h. Okay, and here it will be what? What will be that value? The y coordinate, what's going to be?
F of x plus h.
Very good. So f of x plus h. Okay. So let me just write this point here. Let's identify it. X plus h and f of x plus h is this point here. Okay. Are you with me? Okay, we're building a case here. And what I'm going to do now is I'm going to connect these 2 points. Here we go. Connecting them. Okay, and now what I'm going to do is I'm going to find the slope of this red segment here. Okay, so let's find the slope of this. Can you tell me what the slope here is? Right, it's y2 minus y1 over x2 minus x1, right? Delta y over delta x is the slope or the rate of change, whatever you called it in high school. But that's how you find the slope between 2 points in the Cartesian plane. So y2 minus y1, so that's f of x plus h minus y1, which is f of x, right? You with me? And divided by x2 minus x1, which is x plus h minus x, so it's just h. Let me know if you have questions so far.
Sorry, can you just re-explain how you got the slope?
Sure. Okay, the slope right here. So a reminder, quick reminder. Slope is equal to, so delta y over delta x, which is y2 minus y1 over x2 minus x1. Remember this from high school?
Yeah.
Okay, so this is my y2, this is y1. So y2 minus y1, f of x plus h minus f of x, y2 minus y1, divided by x2 minus x1, which is x plus h minus x plus h minus x. That's just h.
Okay.
Okay? Okay, so this is what, this distance here is what I called h. Any questions before I continue? Okay, so this is very nice, okay? I'm drawing lines everywhere, but what am I trying to do here? I'm trying to find the slope of the green line. And what did I do? I found the slope of the red line. I mean, that doesn't really help me much, okay? It's not bad because it's better than nothing, right? I have a slope here, right? So here's my slope, the red slope here, but I want actually the green slope, okay? So you see they're off, okay? I mean, it's better than if I would have taken a slope like this, right? So I'm a bit close, but not close enough, okay? But what's important to notice is that I took x plus h pretty far. I took it here. I should have taken a bit closer, right? I should have taken it here. If I would have taken it here, okay, then I would have my x plus h, my x plus h, f of x plus h would be there. And my red line will look like this. You see? And that slope now is much closer to the green than the other one. We're much better off here. You understand? So in other words, the closer the h is to 0, right? Well, the line, of course, the red line will be much smaller, but the slope, I'm not interested in the length of the line. I'm interested in the slope of the line. And the slope will be much closer to the slope of the green line. Is this clear, what I just said? That's the important, the key concept here, okay? The closer the x is, the x plus h is to the x, in other words, the smaller the h, then the smaller the red line will be, and the closer the slope of the red line will be to the slope of the green line. Okay, as you see, I don't know if I have something that, I don't know if you can see it like this. Slope here. So the closer I get, closer, 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 closer. You see, closer until it gets almost to the green. Okay, I don't know if I illustrated correctly. Okay, but I'm fixing this point here, and there we go. I'm rotating, 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 rotating until this becomes very, very small, but the slope is getting closer and closer to the green slope. You see? Oh, that was the one I chose. I could have gone further, closer, closer here, or even closer until it falls exactly on the green one. You understand the concept?
Yes.
Okay. So let's go back to what I'm interested in. Okay, I'm interested in f prime of x. Okay, f prime of x is the slope of the green line. Well, that we said was approximately equal, not exactly, to the red slope, which is f of x plus h minus f of x over h, which of course depends on h. Okay, so what should I do to make it exactly the same? I want it to be equal. I don't want any approximations anymore.
You can make the limit as h approaches 0 of that.
Very good. Okay, so f of x plus h minus f of x over h. But now I'm going to take h very, very small, like I showed you with my ruler that turns. Okay, so if I make h very, very small here, then I'm going to get the exact value of the slope. Okay, so this is very important, what I just wrote here. Okay, so this is called the limit.
Sir, we can't see.
Oh, sorry. limit definition of the derivative. Okay, so this you have to understand. It's very, very important. We're going to see this a lot, and you're going to know about it in a few minutes. You'll see. Are there any questions before we go to applying this formula with a few examples? Okay, no questions. So let me do, we don't have much time, but I'm going to do 1 or 2 examples and then we're off for the weekend. Okay. So example. So find f prime of x if f of x is equal to, let's say, 2x plus 1. Okay, so what's going on here? F of x equals 2x plus 1. This is just a straight line, right? We know this, that f of x equals 2x plus 1, y equals 2x plus 1 is a straight line. Okay, what does this line look like? Well, it goes through 0, 1, that's the y-intercept, and it has a slope of 2, right? We know this. That's what the line looks like. This is y equals 2x plus 1. This is 1. Good? What is the slope of this line?
2.
The slope is 2, right? Y equals ax plus b. The a is the slope. Okay? In other words, if I take any value x, any point xy on this line, and I do the tangent, which is itself, because it's a line, the slope will be 2. Okay? So if I apply the formula that we just invented, okay, we should get 2. If we're not mistaken, if our math are correct, we should get 2. Let's try. Okay? So f of x is equal to 2x plus 1. I also need f of x plus h. So what's f of x plus h? If f of x is 2x plus 1.
Two x plus h plus 1.
So it's 2 times, so every x becomes an x plus h. So there was an x here, so the x here becomes x plus h. That's how it works. Okay? Let's go, let's use the formula now. F prime of x is the limit as h approaches 0, f of x plus h minus f of x over h, and that is limit h approaches 0. So f of x plus h is 2 times x plus h plus 1, that's f of x plus h, minus f of x, which is 2x plus 1, and then all this over h. And this is a limit which we know now how to do. We've done quite a few limits, and so we should be comfortable with this. Limit h approaches 0, so on the bottom I have h, and on top I have 2x plus 2h plus 1 minus 2x minus 1. 2x minus 2x is out, 1 minus 1 is out. So I have limit h approaches 0 of 2h over h. h's are out, and so I'm left with 2, just as expected. You guys get it?
It makes sense, but what's the point if it's a slope, directly proportionate slope or indirectly proportionate slope?
Excuse me, I didn't hear your question. What's the what?
Like, what's the point if it's already a tangent, like a straight line? Find a derivative. What's the point?
In this case or in general?
In this case, I mean.
Oh, in this case, well, in this case, I did this for nothing because I knew right away that this slope was 2, right? That's pretty easy.
Okay. Yeah.
But if this was a curve, if this wasn't a line, it was a curve, like we're going to do in the next examples, you'll see that the slope, the tangent changes slope, right? It changes.
Yeah, right. So you're just proving like that the rule works here. Okay, gotcha.
This example was just to sort of validate what we just discovered. Okay, we just said I'm expecting the slope to be 2. Let me see all the process if it leads me to 2, and it does. Okay, so it seems like we're onto something.
All right, perfect.
Okay.
Thank you.